event. I'm very glad to see everybody here. We've had a fantastic 2023 so far, lots of new faces and lots of great talks. So today, our event is brought to you by Hillsborough County for this wonderful venue, so props to them, as well as by USF, and we'll talk a bit more about them in a little bit here. So, Terry, actually, would you like to come up and say some words about USF and your program?
Good evening. Oh, come on, we can do better than that. It's the end of the day.
Come on,
Good evening. So I put my speech together so I wouldn't forget anything, and so I wouldn't especially go over because I am known for that. So we know that tech is on fire in Tampa, and finding talent and quality professional development programs can be challenging. Responding to the need for upskilled talent, USF's Department of Computer Science and Engineering is happy to announce 2 new online upskilling opportunities for individuals and employers, potentially for your employees. These are asynchronous online courses. Now, first I'm going to talk about Pathways to Computing. This is for people like me who have nothing in the computing drawer, okay? It equips individuals with a solid computer science foundation to either A, pivot into tech, or transition into the Master's of Computer Science degree. This program is designed for those with little or no experience. The program includes 8-week classes that you can finish in 2 semesters. So you're taking 4 short semesters. For those of you who started with 0, have a very stressful job, we also have part-time programs where you can do this program in 2, 3, or 4 semesters. So at 4 semesters, you're just taking 1 class at a time. Can we go to the next slide? Awesome. So if you'd like to step into a cutting-edge tech career, then consider our online artificial intelligence graduate certificate. They've designed the AI program so you can learn to build the software that powers every aspect of modern programs. This program involves 4 16-week courses in today's hottest AI topics: Intro to AI, Deep Learning, Data Mining, and Computer Vision. These AI courses can be applied to the Masters of Science in Data Intelligence that is being launched by the College of Engineering, Department of Industrial Engineering, and this program rolls into an online. There's two tracks if you want to go into the MSDI degree. One is online and one is a hybrid course. So we have information over at my table about that. To learn more, so yeah, both of them are online asynchronous. You don't need a GRE if you're going into these programs or going up to the next level of those master's degrees. And they are taught by our highly awarded professors. I know that there's a lot of online boot camps that we see coming out of USF, and I even looked up the FAQ section and it said, is this a real USF program? And it says, oh, we are partnering with USF. So some of those are not our program. But these programs were created to respond to a need for talent, the talent pipeline, and for students who couldn't get into the Bachelor's of Computer Science. Maybe when they were looking at that Bachelor of Computer Science requirements and saw the 3 calculus and 2 physics class, and at that point they swiped left. This course, the Pathway course, has a discrete structures course. It's based in Python, but you'd also learn C, the AI curriculum, all based on creating solutions and programs, mostly in Python. So somebody pointed out a program that UF has, and it says no programming needed, no background needed. This is actually, pedal to the metal. You're creating solutions in these programs. I have this QR code. USF is doing an AI symposium in the fall. And this QR code, and I'm going to pass this around, is a questionnaire, and they are asking you to give them information on what speakers, what topics you would like to hear. So if you're interested, please scan the code. It's somebody that I just met already scanned the code. I don't think it's very long. I'm going to pass this around. So if you would give us some input, we would love to have it. That way we're designing and we're responding to the needs of the people that are right here in our own community. I'm also going to pass around their information sessions that we do online. The next one is not until June. It's June 9th at 1 on a Friday. And if you'd like to come, there are information sessions on our website that you can watch. So if you don't have any questions, you can just watch those. If you think you have questions, then you can scan the code here and register to come. And it's about 30 minutes by the time we go through the program. And then if there are questions, then it'll last a little bit longer. So I'm going to pass one over here. If you'd like to register. I don't have one. I do have my little forest of QR codes over here, all kinds of information. I have one. I'll start over here in case you're interested in looking. Again, the 4 courses: Intro to AI, Deep Learning, Computer Vision, and Data Mining. And those are all our USF professors. I think that's it. Yeah, so I look forward to answering any questions you might have. I thank Tampa Devs for allowing us to come here and sponsor today's pizza. And I'm looking forward to learning something about AI today. So enjoy your brain food after your pizza food.
Thank you so much. Okay, so now I'm going to call on Joseph because we're going to do the spin the wheel thing. This is the first time we've done the spin the wheel thing, and it's because Quixie was down. So this may be the only time. How do I do this thing?
Just click on it.
Just click on it? Okay. So we're spinning the wheel. This is from the list of our attendees that RSVP'd on Slack. Okay, do we have a Max J? Raise your hand. Ooh, he missed out. Okay, we're gonna spin again.
Alright. Wait, what do we win? T-shirt.
We're gonna T-shirt. And those are fresh off the presses too. Do we have a Chris?
There's a lot of Chris in there. Where's Chris? That's it.
Okay, we're gonna do it one more time.
Sorry, that Chris lost.
Joseph, you got
Jennifer McAllister. Oh man, this is definitely the only time we're spinning the wheel. Do it one more time. If the person that this lands on isn't here, we're just gonna throw one of these around. Do we have a Carlos Andres?
Statistically, this is getting improbable.
Yeah.
This is crazy.
Like birthday. Yeah, right. We gotta get some.
Are you guys not just messing with us?
No, I saw my name on there, so it's definitely right.
Okay, we have
I
a
know. There's
Matt York Guidus. I know we have a Matt York Guidus. Congratulations. Very nice. I accidentally closed the wrong tab. You know how it feels. Okay, so speaking of Matt York Guidus, it's now his time to talk about this exciting new mentorship program that we have just launched. So take it away, Matt.
All right, thank you. All right, so I just want to first say thank you to everyone that has completed the feedback survey that we sent out about 2 weeks ago. The idea is basically just to be connecting people that are earlier in their career or farther in their career in some structured way, to basically help transfer those skills and level up and build deep connections. So far, it looks like there's a pretty good even split between people that are less than 3 years, as well as people that are over 3 years. The idea being that someone will at least have everyone, there'll at least be one-to-one that we can match up people. Some of the initial ideas for how it would kick off is starting in May. Mentees would submit a proposal for an idea for a project that they're working on and have someone that would be their mentor to help guide them along the way. Also a lot of other feedback we received is a lot of people want help with interviewing, just feedback on like tips if they're seeing in the job place, how to like approach recruiters and practice interviews, mock interviews, things of that nature. So still in the early stages, but please, if you're interested either in mentoring someone or being a mentee, please fill out the survey. I'll be over there. Talk to me after all of our great presenters tonight. And so yeah, I look forward to meeting everyone, and I'll hand it back to Jonathan. Thank you.
Thank you so much, Matt. Matt's awesome. I like Matt.
You're great.
Yeah. Okay. So, past events, we just had our career forum at USF. That went really, really well. We had some great panelists. People were super engaged. Lots of excellent questions asked of them. You may even see yourselves in this picture if you routinely come to our events. Now, all of the questions, and I think some of the summaries of maybe some of the answers are up on Slido. And did we record that event?
Yeah, we recorded it.
Yeah, we have a recording of it that
haven't
will
uploaded
eventually
yet.
go on YouTube. Eventually.
Eventually, yeah. I'm like really behind on
At
this.
some point. And then we have some upcoming events to talk about. So our next meet and greet event is at Armature Works. That'll be hosted with the Tampa 20s and 30s group on April 19th. Those are always super fun. In May, on the 13th, I'm organizing basically like a mini GitHub festival. So if you have any kind of like interest in source control, DevOps, cloud, etc., this is going to be the place to be. More details are forthcoming on that. We got Bay Hacks, which is our flagship hackathon. Doesn't this thing look awesome? Like we just did this logo. I'll credit over to Vincent there.
That's like 2 months of iteration.
Yeah, but that's a serious logo. But this will be our hackathon for the year. Last year we did TADHack, and then this year we're like, why don't we just do the entire thing ourselves? Because we basically put all of TADHacks together, and we didn't really get that much out of the,
Not really.
just the label. Like we still had to do all the legwork. So we're like, no, we're gonna throw a cool ship on it and make it ours. And that is, I guess this goes over to you now,
Oh
Vincent.
yeah. I'll
Cool.
start off. Yeah. So I'm probably gonna take a break for a little bit, just hosting events, day-to-day operations, because I just got so much other stuff going in my life. But we're always open to having new events, whether it's something that you guys have an idea on that you want to host, like a specific tech talk that you want to host, or like a specific workshop like Charlton's hosting as well, or just anything that you can think of that nature. We're always open for people to put out ideas, or people that want to host their own events through Tampa Devs, and this is something that we're kind of pushing forward as time goes on. So yeah, let me know if you guys are interested at all. We actually have a also like a volunteer position as well, open for if you want to help organize these events to make it real. There's a QR code that goes directly to our job board, which we're just kind of like spoon feeding everything together, right? So check that out if you're interested in helping organize. Definitely have that up as well. Volunteer spotlights. So we had some updates to our code base. Will is not here today, but he actually updated the mega menu on the website, which looks way better than what I originally wrote. So shout out to Will, but he's not here today. I want to go over some of the behind the scenes work that we're doing. Who was here for the career forum? Was anyone here for the career forum? Okay, like 10 people. I figured like it wasn't like overlapping audiences, because like career forums like a different geared audience than what we have today. It's more technical. But I want to go over some of the things that we talked about there. So, we're officially a 501c3 nonprofit organization, and thank you. Originally when I got this letter in the mail, I actually thought it was garbage. To be fair, if you guys have ever run a business before, just any sort of like, you step like an LLC or anything, you get like so much spam that you just assume it's garbage, right? Just looking at it from the get-go. So when I got this, I had it sitting there for a month. I didn't even know I had it, and I tried to check the mail and just had like it lying through my garbage of stuff everywhere. And so I just cleaned up my apartment. It's like, oh what? We have our 501c3 nonprofit status approved already. And then I posted online, and then a bunch of people are trying to like ask for that letter of designation to spoof Tampa Devs. So I'm like, okay, I should probably take that off social media. But this is a redacted version that's kind of like, safe to post online. At least that's what my account says. Anyways, going on to that, we have a lot of open source projects going on behind the scenes. So like we have our Tampa Devs website, which is at the very top. We also run a thing called Tampa.dev, so it's like gonna be like our portal for all new upcoming events. And if you want to like subscribe to volunteer or see like other partner organization, all their events, we'll have that up as well. We have a job board at apijobs.tampa.dev. We actually have bayhacks.dev, which is our hackathon website that we have coming up. That's the fourth one. My friend Doug is working on that. We have short links, a bunch of other things, something for job syndication. We just got a bunch of like repos that are all publicly available if you want to check it out. So we just got stuff that we're working all the time. So we got a lot of like automation infrastructure work that we're working behind the scenes, which honestly this seems like entirely overkill when you're just like looking at it from the outset. And you might be thinking like, aren't we just a meetup, right? And some of you guys already saw this one already, so I'm just kind of rehashing just parts of it. Aren't we just a meetup? And to reiterate, we're not really just a meetup. We're actually a 501c. Well, these are just meetups. Sorry, these are just meetups. So, I don't remember my own slide deck. I'm so sorry. So these are also just meetups. And what happened was when the organizers of the meetups effectively moved cities, moved different places, had different things in life that they had to prioritize. A lot of these organizations kind of fell off. And that's just kind of the reality when you're running organizations like this. So we're trying not to kind of follow through this like caveat or kind of this pattern. So we're thinking of like long-term infrastructure, long-term planning, long-term vision to kind of like keep things up and running. Like after me and Charlton Senior, and then after Joseph Senior as well. Like we're thinking like years on the road because we want this to be sustainable for the future. And so what we really are is we're a community of software developers seeking to grow together. And these are just some of our past events. So we do networking talks like we have right now, tech talks that we're seeing right now. We have networking mixers at Armature Works usually. We also hosted a hackathon last year in our career forum just 2 weeks ago. And we also have an active Slack community of like 40,000 messages being sent already. So there's a lot of we're just much more than that. And I kind of want to talk about the future Tampa Devs a little bit more. This is kind of rehashing over what we talked about at the career forum. But, I'm like, when I started this group, I kind of didn't want to make it like a legal entity or even a business, or now it's a nonprofit 501c3. I was trying so hard to avoid doing it because I didn't want to do that at all, because I know once you make it into that kind of group, it becomes like the legal commitments and financial commitments and all these other things. But that was essential when we were hosting the hackathon because we had to act as a financial intermediary to like actually put that together. One day I'm gonna be a grandpa, not figuratively, but literally speaking. I'm just like, I've already been hosting events for like 3 years, even though we've only done this in a year and a half. I did this in Orlando Devs as well, I was one of the board members there. But effectively, like, one day I'm gonna retire, one day Charlton's gonna retire, one day Joseph's gonna retire, even though you started. So this is just like the question of, will Tampa Devs run its own after our tenure is up? And that's kind of like, I kind of want to mention this just like as a long-term plan and long-term future thing because it's important like for everyone to know. At least I think so. So Sunday we'll hand it off, and like I said, Charlton stepped up like last year. I was just hosting an event at Armature Works, and we had like 200 people there, and actually Armature Works was like kind of getting really angry at us for congesting the lanes because we had 2 people there, and they're like, You sir are causing a fire hazard here. You cannot block the front entrances with all your people in front of the AW bar. And Charlton was there that day, and he witnessed all of it. And I think I almost got kicked out or probably even banned from Armature Works, but I don't think that didn't actually happen though. But I felt like I was on a blacklist somewhere in like some manager's room.
That's why he grew his hair out.
So I grew my hair out, so you can't really tell anymore. But yeah, every time I go there's always a security guard that just like looks at me particularly. I don't know. Anyways, Charlton's done an amazing job just like helping out on Tampa Devs. He did set up all the AV today. Yeah, sending the love message right there. A lot of infrastructure you don't see behind the scenes, Charlton actually did. So it's like when you're building like a website, a front end website, like everyone thinks it's amazing just because like the front end website's amazing, but like the back end infrastructure is like keeping everything together behind the scenes. So Charlton's been helping a lot on that. So props to that. And we also have a new third co-organizer, Joseph, right here. Joseph's been helping out. He's been organizing some of our networking events. Joined like 2 months ago, I think.
Yeah.
And yeah, you've just been killing it, man. So props to you as well. And
all the digital marketing stuff too.
Oh, and all the digital marketing stuff too. That's true. Like branding and marketing is super important, even though it's just like you're running a meetup, but a lot of people don't check meetup, and a lot of students only use WhatsApp, for instance. But yeah, that's just kind of the thing. You know, one day we'll have another fourth organizer. You know, that's just like down the chain. You know, we're going down the chain of people and organizers. When I first started this, I didn't think of any of this, honestly. I thought just like, oh, I'll just run it and stuff will happen, and now we're here. So, and we also have a lot of awesome financial contributors and sponsors helping us out for providing the food today. Shout out to Terry from USF, thank you so much. And also Lynn from HCC for providing the venue. And we also have a lot of co-contributors too, shout out to them as well. Yeah, so I screwed up the transitions. Anyways, you know, one day this could be you. Like, you can make Tampa Devs your own. And I'm going right to left now because I put the thing out of order. I don't know why I did this. But ever since Charlton took over, or at least a lot of the stuff that I was originally doing, like, I don't know if who's been around here since like we started? Anyone? Anyone who's been around since? No? Nobody? Okay. All right. Well, a lot has changed since Charlton joined, and we've been having a lot of like much better, nicer presentations for sure. A lot more back-end infrastructure for handling a lot of these things behind the scenes. But also, if effectively at the very end of the day, like it's a good opportunity to learn new leadership skills, and you can kind of think of it as like a stepping stone in your career if you want to become more into like lead dev material or management material or anything like that. This is also an opportunity for that as well. And you can learn a lot of infrastructure that we set up behind the scenes here too, that you can like use in other jobs or whatever you want, startups, your own thing. So just throwing that out there. And maybe a decade now, this kind of like a, I just pulled a random image, but don't judge me for this. But you know, I'm not King Charles III, but just like a significantly much lower version. Like probably not even, yeah, anyways, I don't know what I'm talking about. But just think of like this like the way it's organized. Yeah, just think of that, the portraits. So, you know, a decade from now, we're gonna have lots of other leaders that are kind of leading, falling through Tampa Devs, and that's just kind of what I'm hinting at. To kind of go back on like our vision, our impact, kind of like our goal as a community. We're trying to host bigger and better, more fun networking events. So we did that with the Career Forum. We did that last year at the Hackathon. Tampa Bay is like one of the growing fastest cities in the country for tech, according to Forbes at least. We're trying to build more career building experiences and give mentorship to students and organizations at USF, UT, as well as HEC. And then there's going to be a lot more support for logistics and financial support for other like specialized meetups, whether it's Tampa Bay DevOps or the data science group, for instance. And then really far down the road, we want to do monetary scholarships to some degree to people that are struggling financially, that are transitioning careers, or like starting their career for the first time. So that's kind of our goal and our vision mindset. And this is like stuff that people have told me at one point or another when I first started Tampa Devs. This was like stuff in the first 7 or 8 months. Everyone loves this quote, Walt, that I just kind of like, I just wrote down everything that someone told me at some point, and I just put it all down on this. And it gives you better perspective what you guys think of Tampa Devs, and it means a lot to me. It means a lot to all of us on the leadership board. And so this is kind of like a way to remember like what we're doing this for. Yeah. Oh, and then we have a blog site, by the way, if you want to read more about this stuff. It's just tampadevs.com/blog. Sorry, I'm like tongue-tied right now. And more things. We have a community page, with just some of our groups. We have a little job board as well that's indicated to our Slack, as well as through job alerts. We have a swag store as well. We
Look
just got
at these new shirts.
we just got new shirts in. They're purple now. It's actually, yeah, purple now. We have purple and blue actually. So if you guys want to buy a shirt, they're $25, I think, Charlton, right?
Yeah.
All right, yeah. And then we have a donation page as well if you want to support at Tampa.Devs/donate. And here's all of our social media, and I think that's it, right? All right, and I want to. Oh yeah, we're also looking for new speakers all the time. So if you want to give a talk, hit us up at speakers@tampadevs.com. And I want to give the floor to David. David right here. David Korchid, also known as DavidKPiano. So to kind of give some context, David's all the way from Orlando. He drove like, how far did you drive? An hour and a half. Yeah, so you drove an hour and a half to give this presentation. So thank you very much, David.
Yep.
So David and I go really long ways back, right? I think 4 years?
Probably
Four years, 5 years?
Yeah.
I was still a new developer with absolutely no skills, and I was still learning CSS. And I used to go to David's CodePen meetup down there to learn just like how to like draw like a little piggy or something. Which I wish I could pull it up. I have a CodePen, but yeah, David taught me so many different things, and you know, I think like when we had the Orlando Devs reunion, I came back like 2 years ago. This picture right here is actually what kicked off Tampa Devs. Originally, I was just meeting up with friends. I brought 2 of my other friends with me, and then they're like, "Oh my God, you should start something like this in Tampa." And then that's kind of the thing that kicked everything off. And yeah, I knew David before I had a beard. So in case you guys probably never seen me without a beard, but anyways, yeah. So I want to go hand it off to you, David.
Here you go.
Thanks.
Let's see if this works. Hold on, let me set mirroring here. Oh gosh. All right, talk amongst yourselves while I do this. Can I hand that back off to you while I figure it out? Okay.
Okay. Who knows anything about state machines? Anybody? What do you know about state machines?
Well, they're the basis of any Turing machine.
Turing machine? Okay.
Turing machine is the basis of all our computers.
That's true.
State machine, basically, describes a whole bunch of things. Like there's states, right? Which basically describes the state of a program. And states are connected by transitions, which are
Okay, for those of you who suffer through computer science, think of a state machine as kind of like squares on a board game. The squares are the states, and then the transitions are the arrows that connect one state to another. That's pretty much it. David will do a more thorough job of explaining what state machines are.
state machine itself is a pretty straightforward concept, right? It's a machine that keeps track of the state.
And I believe David is talking about finite state machines. I could be wrong.
I have a graphic. Do not need your machine.
All right. So hello, my name is David, and like Vincent said, I drove an hour and a half here from Orlando. Don't worry, I work remote. I know some you're like, oh, Orlando. You know, it's almost as good as Tampa. You know, but I like Orlando. Anyway, so I'm going to be talking to you today about two of my favorite things. One I've been obsessed about for a very long time, and one of them is more of a recent interest. So state machines. I've been obsessed with state machines for a long time. When I started working in Orlando, I was a junior developer working on this really complex application logic, and I just couldn't understand it. And so that's where state machines came in with its visual formalism, which I'm going to show you, and it really helped me understand things. But now things are changing. We have artificial intelligence, or more specifically, generative artificial intelligence that's really permeating through our entire lives right now. So yeah, my name is DavidKPiano. I'm at DavidKPiano, and I work at this company called Stately. We're at stately.ai. I founded this company because it was the pandemic and I was bored, and I really wanted to do things with state machines. So yeah, first of all, state machines are really useful in many, many applications, and one of my favorite things to do is to program complex components using state machines, and one of them is the command palette. And so the command palette is actually one of my favorite UI components because it really just, like, I know people might have like date pickers as favorites, or like, you know, buttons or things like that, but command palettes are super, super versatile, and you're seeing these in many applications. So how many of you use like VS Code, or, you know, things like that, or even like Mac? Like, the command palette is probably something that you just go to all the time, just because it is a very quick way of accessing anything that you need to access. So the idea is that, you know, without using a command palette, you would have to find the right place in the UI, you know, maybe click around and click and try to figure out, all right, where is this button or this field or this form that I need to access to get to something, and then type the right thing, and then hopefully you get to your goal. You get to what you want to do. With a command palette, it's really short. You just type what you want to do, and then, you know, you're at your goal state. So it's extremely convenient. And so something new as of, well, November 22, that's really been acting like this has been ChatGPT from OpenAI. Now, this talk is not going to be completely about ChatGPT. We are going to be talking about AI, but I feel like there's a huge difference between generative AI and the AI that has existed before and the AI that's going to come after things like ChatGPT and LLMs. And we're going to talk about like just how how that kind of AI and state machines work together. So with ChatGPT specifically, like, you give it an input and it does its whole magic with LLMs, which stands for large language models, which you could just think about these huge graphs of like associations between words, so that it could predict like what is the next string of words given your input, and it's like, okay, here's the probable next sentence that follows from that input, or prompt as it's called, into an output. What I'm more interested in is starting somewhere, presenting an AI with a goal, and an AI figuring out every single step to reach that goal. ChatGPT fundamentally cannot do this, neither can any LLMs. Now, with tools, it could sort of act like it does this with LangChain and stuff like that, but there's a more fundamental field in AI, which we're going to talk about soon, which does get us to this. But first, let's talk a little bit about history. Back in, I think it was the 1960s or so, symbolic AI was all the rage. And symbolic AI, it didn't require any large data sets or guesswork or anything like that. Instead, it had these relations between different topics, so that it could determine, like if you said, you know, David lives in Orlando, Florida, it made that relation David, Orlando, Florida, so that when you asked the question again, like, where does David live? It's like, okay, we have the relation that David lived Orlando, Florida. Like, it draws a graphical representation of all that. But this didn't exactly scale, just because, you know, human language is messy, semantics are ambiguous at times, and the real world is really complicated. So that quickly fell out of favor. But it was interesting because it did provide like this way of, or at least a very, very basic way of reasoning about the world, more than just stringing words together and hoping that it was the right sentence. Now, another form of AI, which is also really basic, is state machine AI. And this is something that probably every single one of you has interacted with, probably directly or indirectly. For example, if you play video games, such as Halo, or I mean, you know what a video game is. I don't need to give you an example, but enemy AIs or NPC AIs or whatever, most of those are probably powered either by state machines or by behavior trees, which you could think of as an abstraction over state machines. So in this example, if you don't know what a state machine is, this is an example of a state machine. So this is a state machine for a ghost in Pac-Man. So we have over here the initial state, which is wandering the maze. And then a few things can happen. A ghost could see Pac-Man, and depending on the ghost's behavior, the ghost could decide to chase Pac-Man. And then when Pac-Man eats a power pill, then the ghost is going to have a different behavior, which is running away from Pac-Man. So when the power pill wears off, then it's going to go back to wandering around the maze. But if the ghost is eaten by Pac-Man, it becomes these weird little eyes, and then it just returns to the base, and when it reaches the base, then it's going to wander the maze again. Now, in reality, the state machine for the Pac-Man ghosts are a little bit more complex than that, but essentially, this is how you would program AI agents in video games and things like that. And what's interesting is, as I was researching this, I got on this little rabbit hole about Pac-Man, and I learned that each one of the ghosts actually has distinctive behavior. So for example, Blinky will just, it will just try to chase Pac-Man, and it will find the shortest path in the maze to reach to where Pac-Man currently is. Pinky, on the other hand, predicts where Pac-Man is going to be, which is a little bit more interesting, so it's a little bit more intelligent. So if Pac-Man's going this way, Pinky is going to try to intercept Pac-Man. Inky sort of teams up with Blinky, and so it tries to box Pac-Man in, which is pretty tricky. While Blinky is chasing Pac-Man in a very basic way, Inky is just finding that intersection and being like, all right, we're going to trap you in. And then Clyde, I don't know what Clyde does. It just wanders around the maze or something. But then after that, in the 90s or so, deep learning actually became really popular, deep learning and neural networks. And if you're not familiar with deep learning is a way of trying to simulate how the brain behaves, or at least how brain neurons behave. So you're basically transforming something and extracting higher level features from that using many hidden layers of neural networks to do that. And so this is useful in classification and regression problems. And I'm sure that USF course will teach you all that if you want to sit through 16 weeks of whatever that is. It's exciting. I just did not like college. So anyway, artificial general intelligence. So this is also a topic that's been brought up. Whether that's real or not, it's no one knows. It's hard to define, and we keep moving the goalposts on this. But generally, with artificial intelligence, we need something more than what we have today. First of all, we need something that has an actual mental model of the world, of the universe, of whatever it's interacting with, not just something that regurgitates a statistical, string of words that sounds correct. Also, it needs to have a perception of time, understanding that things change over time, and things influence other things, and these things happen across the spectrum of time. And of course, it should also have an imagination, because it can't just be a linear, all right, when you give me this input, I'm going to give you this output. It needs to be creative. It needs to do problem solving. It needs to reason about the world. And you need imagination and creativity in order to do that. So whether AGI exists or not, we do know that the current AI of today, while there's lots of huge advancements, we know that we could go a lot further than that. And so that's why I think that right now, where we are, we're still many, many years away from AGI. That's just my current stance. Is AGI impossible? Does it exist? Who knows? Whatever it is, we're still many, many years away from it. So I want to talk about this topic in artificial intelligence called reinforcement learning, which is a framework for modeling AI agents in the ways that humans and actually animals also behave. So the idea is that you have an agent, and an agent takes an action in an environment, and so when that action is taken, it observes what happens, which is that state, and it could get a reward for doing the correct action. So let's take Pac-Man as an example. The environment is the maze. It's the maze, the dots, the fruits or pills or whatever they are, the ghosts and everything. And this environment can have different modes too. So, for example, or you could think of them as states as well. So in normal mode, Pac-Man is just wandering around eating pebbles, and in scatter mode, you have the ghosts chasing Pac-Man. So now your environment is different. And based on actions that occurred, so in this case, it would be Pac-Man eating a pebble, the state of the world actually changes. And so you could observe this with yourselves, just turn the light on and off, you'll observe the lights change. So it's not that your world has changed unless you have a revelation when you turn the lights off or something, but like you could notice that things actually change. And then you have the agent. So before we talked about the ghost as the agent, which it could be, but let's consider Pac-Man as the agent. So an agent is responsible for observing the state of the environment, sorry, and then taking action. So when you're playing Pac-Man, you are actually the agent. So you are consciously deciding which direction you should go. What should I eat? Should I eat that pill? Is it a good time to go north, south, east, or west, or eat a pill and then chase a ghost and then eat some of the ghosts? And you're also trying to find the shortest path to get to finishing the maze and eating all the pills. So you're taking actions based on the state of the environment. And so, for example, if you're being chased by a ghost, you might take a different action. You might be running away. And also, if you ate a pill, you might be doing the opposite. You might be chasing a ghost. So this all falls into a policy. And a policy in reinforcement learning is that given some states, your policy is what determines what action you should take next. And so sometimes it's pretty straightforward, and sometimes it's a little bit more ambiguous. Like there's no right answer, which is why sometimes there's a stochastic policy, which means just make a random choice. And so in this case, like depending on what the environment is, the policy will say you should move up, down, left, or right in order to potentially get to some desired state. And then of course there's the reward. So as you're playing Pac-Man, if for example you see a ghost and you say, you know what, I'm gonna go right towards that ghost, and you get eaten, and then it says game over, and you don't have that many points because you only collected 2 pebbles before getting demolished by Pinky, then your score is gonna be really, really low. And so when you play again, you're gonna learn, you know what, maybe I shouldn't do that. Maybe I should actually avoid the ghosts. So you're going to learn from that, and you're going to adjust your policy so that you could maximize your reward, which is a key part of reinforcement learning. And so rewards could be, it could occur at the end where it's like you don't know that you're getting a reward, you don't know that your actions are actually good until you finally get that reward, or they could be more immediate. So you could say, oh hey, when I get a cherry or a pill, that's good, I get a lot of points and I get to eat ghosts. Also, when I hit a ghost, I immediately know that that's really, really bad and I lose a life. All right, so there's also the model. And so the model is basically the agent's perception of the world, its understanding of how things work. So for example, Pac-Man knows it could go up, down, left, and right, but we shouldn't program it to a specific model because you don't want it to memorize a certain world. You want to have a policy that works with just changing models, because that's what makes reinforcement learning effective, is that you're not hard coding a certain model into it. Now, all right, so with reinforcement learning, there's lots of shortcomings. First of all, with learning, you need a lot of trials. Basically, these systems and things like AlphaGo and AlphaZero, they're trained on billions and billions and billions of games, simulated not only with humans, but also with itself. And so you need a lot of computing power to do that. There's also combinatorial state explosion, which just means you can't, there's a near infinite number of possible states that you could be in. And also the simulation is not like real life. Like what happens in the simulation does not necessarily reflect the real world. And also, I put here there will be consequences, which sounds threatening, but all that means is that whatever you do, like with a reinforcement learning agent in a simulated world, you have no consequences. Like it's not like someone's going to die like in the game. Like it's not like you die in the game, you die in real life. But if you try to train a reinforcement learning agent in the real world to do things like self-drive a car, guess what? You could hit someone. So, maybe don't do that. Maybe use a simulated environment. And also with planning, you need a lot of trials, and there's also a sparse number of rewards. So you don't immediately know, like I said, which action is good or not. And so you have this problem of exploration versus exploitation. So just to explain this a little bit, exploitation means I did a sequence of steps, and I knew that I got some sort of reward from those steps, so I'm just going to keep doing those because I know that it's pretty good. And if you exploit 100% of the time, you will learn nothing. It's sort of like, like, I don't know, walking to work and then not learning that there's these things called bikes and scooters and cars and Uber and stuff. And so you're just taking the longest path every single time because well, at least I get to work. There's also exploration. And so with exploration, it's like, you know what? I'm going to try something new this time. But the problem with exploring 100% of the time is that you also learn nothing because you don't fine-tune and like have a single path that you're like, okay, this is the best way to do these things because you're always exploring different things. So just to demonstrate this with dogs, like how many of you have a dog or a cat or some living thing that you train, like children? Okay, so a bunch of you. All right, so you know that when you're teaching your dog how to do tricks, like let's say you tell your dog down or sit or something like that, obviously the dog doesn't know English. It's not going to do anything. And you have no reward, so nothing changes for the dog. But now let's say that you have a treat and you tell the dog down, and I don't know about your dogs, but sometimes like dogs just try everything in the book. Like they're like, I'm gonna spin, I'm gonna jump twice, I'm gonna fetch or whatever. I'm gonna just try everything so I could get that treat. And so when the dog goes down, you immediately give the dog a treat, and then you praise the dog, and the dog realizes, wow, when the owner says go down, and I get a treat. I get the reward. So what's going to happen next time is the dog is going to exploit that and say, when you tell the dog go down, the dog's going to think, you know what, if I go down, I will get a treat. And that's really awesome. So whether it gets a treat or not, at least it's not being punished for going down when you told it to go down, so likely the dog is going to continue to go down. But then there's also exploration, where you say go down and let's say the dog runs away. Your dog thinks like, you know what, I might try something new this time, and then you punish it by screaming at it or whatever, then that's an undesired outcome for the dog. So it's going to learn that it probably shouldn't do that anymore. And so if you were to map this out as a state machine, then the down action, basically, it reinforces that the dog should probably go down, because if it follows that path, it is very likely to get a reward. And if it does something else, then this is negative reinforcement. So it's not going to get a reward, it's going to get the opposite, so it's not going to choose that path. And so basically the dog is trying to optimize the shortest path from not having a reward to having a reward, and it does that by following the arrows. So with sparse rewards, you don't really know, what actions are going to happen to get a reward, but eventually when you get a reward, you could remember, oh, those actions I did previously were probably good actions. And so with Q learning and reinforcement learning, you basically assign a reward to each of those actions, but you say, the reward isn't going to be as strong as the most recent action that I've done. And so I could go all into Q learning, but we don't have too much time. But yeah, so I've been thinking with state machines and reinforcement learning, how can we improve reinforcement learning? And so in my opinion, I feel like we could use one of the oldest AI techniques, in combination with reinforcement learning, which is state machines. So here's my thinking, and this is all like really experimental. It's something that we're playing around with at stately.ai. If we model the environment as a state machine, and this is a state machine that is either it's learned, it's synthesized, it can be generated. It's not something that you have to pre-program at the very beginning, and it could also be adapted. So as an agent learns new things, you could add transitions to the state machine. The states are finite states, and you could collect these finite states and group them together by common attributes. The action is basically you're determining what can I do that's part of the shortest path to get to some goal state that I want. And the reward is how well does the expected state reflects the actual state that I'm in. So basically, you have a model of the world in your head, and you're thinking, okay, I know how to reach some sort of goal state that I have, and as long as every single action that I'm doing reflects my understanding of the world, then I know that that action was correct. So that would be the policy. And so, like I said before with LLMs, you don't have that idea of reaching a desired goal. You just have two things, input and output. Now, if output is your desired goal, then that's fine. LLMs serve their purpose. But LLMs cannot really figure out how to get to a desired goal. It could give you a list of steps and tell you, here's the probable way of getting to this goal, but it could be wrong. Like, it could have a step that's wrong, and then it just extrapolates from that step and just gets further and further away from the truth. And so, with reinforcement learning, what's cool about it is that agents actually are learning from their environment continuously. So if an agent tries an action, does something wrong, then it's going to correct itself and then figure out a different path in order to get to the goal. And so, I'm not going to use this example, but I had a little feedback example where I had a form and we modeled it as a state machine, and then I showed how reinforcement learning can navigate through this form. Because I'm using a different computer, I'm actually going to just show a video of it. But so the steps that I had in mind were, first you would model the environment, so you would determine what's the current state, what's the action to execute, and then what would be the next state after that action is executed. And then these could actually be modeled directly from things like user stories. So for example, given a feedback prompt, when I click good, then it takes me to the submitted screen. So if we were modeling some sort of feedback form, you could do it that way. And then you determine the goal state. So this is actually one of the most interesting parts. It's not the entire way of how this would work, but with LLMs like ChatGPT, you could give it a plain English description of what you want done, and it could convert that to a goal state. So that's where LLMs are really good. Not necessarily for determining what are all the steps to get somewhere, but for converting a plain language description to a goal. And so, we could also use LLMs to generate the event data. And long story short, we're finding the shortest path from that initial state to basically how to reach the goal state. So I'm just going to show you what this looks like over here. So I'm not sure if you could see it that well, but here's what this video is showing. I have a script running in Puppeteer where I'm not actually pre-programming like here's how to add a to-do to a to-do list. Instead, not sure how well you can see that. Can you all see that? Yeah. Okay, so for those of you who can't see, I'm typing a string here that says, we should build an awesome AI bot and a great diagramming tool. And then, so that's all I'm typing. And then I'm pressing play. So what's going to happen here is that I'm going to send this to OpenAI. It's going to translate that not to a sequence of steps, but instead to a goal state. And then we're going to use that goal state and our state machine that's generated from to-do MVC, and we're going to find the shortest path from opening to-do MVC to reaching that goal state. So I press play. It's going to pop open a browser. It's going to hit the OpenAI API, and it's going to eventually, takes a while because it has to hit that API, it's going to add those two to-dos. So, yeah. And so from that demonstration, there were a lot of learnings. First of all, large language models are unpredictable. When I was running this, I actually found it to fail, like 25–50% of the time, just because it didn't exactly fit the state's shape that I wanted it to fit. But this is something that could easily be fine-tuned so that it gets closer and closer to 100%. And especially with GPT-4, that becomes a lot more reliable. Also, it made me realize that state machines are really, really, really useful because they're not just useful in modeling your application logic in a visual way that makes it really easy for people to understand, but also it's really useful for for things like artificial intelligence and basically using it for reinforcement learning to determine what are the shortest paths to get from my initial state to any other state that I want. And so this is really useful in things like guided tutorials, even command palettes, and using that to just help your user do whatever you want to do. And also, I believe that reinforcement learning, whether AGI exists or not, it gives us a lot of insights into AGI, and in general, graphs make a lot of things possible. And I want to show one more thing just to demonstrate how awesome, actually just kidding, I have to sign in and stuff. My laptop's not working. So anyway, come find me afterwards and I could show you some other cool demos. But anyway, I feel like we can make our apps intelligent today, and that's through the use of state machines and reinforcement learning and all of that. So thank you very much, Tampa Devs. Oh, yeah. Any questions?
Me.
Yeah.
Yeah, so it's like large learning models like GPT. How exactly does it find a goal state?
Oh, so what I'm doing, at least what I was doing in that demo, is that, all right, so step one is you're basically letting an agent crawl through something like to do MVC, determine okay, here's all of the states. So it makes a state machine from that, right? And so there's a representation of that state machine where, for example, it would show you that my goal state in having those two to-dos is that I have an object with an array of two to-dos, and both of those to-dos are not completed yet, right? And so it's find me all the possible paths that reach that state. And so basically it's just converting it to JSON. But that JSON needs to be understood by the state machine, if that makes sense.
Well, how does it create a state machine in the first place?
Oh, so this, I could talk about this for a few more hours, but this is, I won't though. It's a topic called state machine synthesis. So long story short, you have something, it's sort of like a website crawler, like what Google does, except you are not crawling through pages, you're crawling through different states in an application. And so you're basically, for example, you're on one page, you're like, okay, what are all the things I could do? I could click a button, I could fill out a form, I could click this link. So you do that, you observe, okay, this is the state I ended up in by doing that, and then lather, rinse, repeat. So then you would go back to the beginning, try something different this time, and then after a while, you have basically your state space of, all of your states and transitions, and then you could use that. And that's your synthesized state machine, in a way.
So it enumerates all the possible states.
Exactly.
Okay.
Yeah.
So it does that exploration step to graph the space to be able to find the shortest path? It doesn't know shortest path ahead of time.
Yeah. So it's not going to know the shortest path ahead of time because you could give it any number of to-dos. And so the idea, what I had in the demo, is that from that goal state, hey, fill it out with these two to-dos, it's not only finding okay, what is the probable final state that I have to reach, it's also finding out what are the events that I need to send the state machine. So the events would include fill out this to-do with this specific text, and fill out another to-do with this specific text. And then it figures out from all the states I know, what are the combinations of states and transitions that get me to that final state.
But it doesn't know them ahead of time. That's the thing, I'm still trying to,
Well, so no, it doesn't know them ahead of time.
so that's like exploration? Like
Yes,
not
yes, it's doing an
exploring
exploration.
to find what they are, and then once it knows enough of them, it find the path. But it's still not necessarily gonna converge on the shortest path.
Right.
It would have to enumerate all of them, and have that combinatorial explosion.
Right, no, so it wouldn't do, it wouldn't do like all like possible states like from the very beginning. It would have to, so it would have to have a model of like, if I add a to do, like not with this specific text, but like, you know, adding it with,
Yeah, that's okay.
right, then we'll talk about it later. Yes?
Do you have like good workflow examples or documentation on how to use Stately with and Unreal?
Oh, with Stately and Unreal?
Like, is there like good just like workflow, like how to just use them in conjunction, how to like interface them, I guess?
I'm not too exactly sure about that, but I could tell you that if you go to like stately.ai slash
I didn't do
editor.
the due diligence, so I didn't check.
Yeah, so I just want to show this real quick. Hopefully it works. But this is a state machine editor that, ooh, the mouse is inverted. I'm not used to that. So this is basically like your state machine tool. And so, you know, you could create states and transitions like that, and you could, you know, just edit these. And then depending on what tool, you know, you're using, I guess Unreal, there's many different export options, or there's 3. There's JSON, JavaScript, and TypeScript. And so you could actually take this JSON and you could make it work for Unreal.
Oh my gosh, okay, amazing.
Yeah.
This is really cool.
Awesome. Yes?
Yeah. What was, if you could speak at a high level, what was the structure of the prompt that you were feeding in to GDC for that API?
The code's not on there. But so the structure of the prompt, and so this actually speaks to his question a little bit more too, is basically once you have determined like the state machine, and again this is, so the state machine that is generated, it's like a blueprint. It's not like the actual, here's all the possible combinations of words and to-dos that I could possibly fill in. It's more that like if I fill it in with a text value, then it's going to show that text value in this field. So it has, you know, that correlation. But when I'm actually creating the prompt, it's saying like, okay, here is my, you know, state machine. Figure out like, you know, given this prompt from the state machine, what is the possible like state representation? I'm trying to figure out a good way to say this, but basically we would have a JSON schema like object that says, here's my state value and here's the possible values. My possible values could be to do filled out, or, you know, to do completed, to do not completed, etc. And here is my context. And so my context could be something like message string. And so this speaks to your question too. So that's what I'm telling the LLM. I'm saying like there's a message, and the message could be a string. There's also a, you know, for example, a completed attribute, and that could be true or false. And so when I say I want to fill out this to-do with buy groceries, then it could say, okay, you want to have completed, true, and message buy groceries. So it sort of understands how to do that, and that's the magic of LLMs. And so from that, we take that and we also extrapolate like what are the possible events. And so a possible event could be to-do.add, and the payload could be buy groceries. And then from that, it figures out, okay, here's the shortest path to get from where I am to filling out the to-do.
I know that doesn't work 100% of the time, but it must have been wild to see it work for the first time.
Yeah. Took me a few tries, and I'm like, oh wow, it works, so I recorded the video. So.
To your knowledge, where is it being, the state machines, where are they being used today in real world? And the same regard, where it should be used or it can be used?
That's an awesome question. So state machines are actually being used everywhere, front end and back end. A lot of the time state machines are implicit though, in which we just program Boolean values, and we have these implicit states in our application, and we don't really fully know the the actual state machine, for it. But actual explicit state machines, they're used heavily in embedded electronics, game development, and now with Stately and with everything that we're doing, they're being used more and more in front ends and back ends. So actually, if you consider any workflow where you have a sequence of steps, like do this, then do that, then do that, like a CI pipeline or something like that, technically that is a state machine, and it is a more explicit state machine than just coding it and then hoping that the right things happen in the right order. But it is a very basic state machine because you have step 1, step 2, step 3, so you don't have the concept of branching or loops, or at least not that much. So yeah, they're being used in a lot of places, and I do think that they should be used in more places.
How do you extrapolate it to be more real life oriented? Say in the sense, so we talk examples like say automated car driving, or even in cases like say chemical reactions.
Mm-hmm.
How do you bring that into a state machine kind of a model? Is it possible?
I believe it's possible. This is sort of outside, my realm of knowledge, but I know that there are papers published on biological state machines. So state machines are used in, in modeling biological processes, and so that could be an example of that. All right. Well, if there are no more questions, then thank you all very much for having me. And I'm here, so if you want to talk.
Thank you so much. That was a great talk, David. Now we have another speaker, is Sindhu. She's going to talk about generative image AI. This is her first talk with Tampa Devs, so it'll be a big one.
Oh my God, did you say?
What's your first talk with Tampa Devs?
Oh yeah. Oh, okay.
Hey, my name is Sindhu. I've been attending Tampa Dev meetups for the past year, so I'm giving a talk on the state of generative AI, which is stupidly broad, and so I'll be presenting like a few different topics. It might be a little helter-skelter, but that's just because this talk is just more of like kind of like a starting point for you to kind of do your own research. I haven't figured out a way to explain how some of these models work in like 2 minutes per slide. You really do kind of have to spend like 15 minutes minimum, even at a high level, to start kind of for it to click. But yeah. So I'm Sindhu, I'm a developer, I'm a Tampa native. I actually worked in Ybor City. I don't come here very often, but I worked in Ybor City at a company called Samtira, and I think their like board was up there for like a really long time. But it was like a cloud computing company back when AWS didn't exist. So nothing like that would ever be funded today. I'm a full stack engineer at a company called TSYS Interactive. It's based out of India, and we do big like digital transformations for very large enterprise customers. And I work in an innovation design studio based out of the other Bay Area. And I came here during the pandemic. Technically, right now I'm working out of Atlanta. But yeah, I'm really passionate about design, and I work on a design team as a developer. So we do a lot of like game stuff. So the state machine talk was like super, super cool and exciting. I remember seeing it in school and thinking like, oh, I don't need to know this, like, I'm never gonna build a vending machine. Super useful later, I realized. They never really make that linkage, I think, in classes, which is unfortunate. But yeah, talk to me later about like if you like design and accessibility kind of topics, really passionate about that stuff. So, generative AI, this is like, this is gonna be like a charcuterie board, so take from it what you may. Hopefully I do more good than damage. So what is generative AI? Obviously I asked ChatGPT. It's a class of artificial intelligence that can generate new content or data, such as images, music, text, based on patterns instructors learn from training data, is what it told me. So it's really funny because Sam Altman, the CEO of OpenAI, made a comment in like an interview that the biggest systemic mistake that current experts in the field of AI make is, thinking that AI will generate new, like fundamentally new stuff. That's not really true. AI just does what other people have already done. It's not going to, in his words, add to the sum total of human knowledge. Generative AI creates data probabilistically, and it's only still today, through like genuine human creative process that we can actually make novel things. So just wanted to start the conversation with that. So what are people doing with generative AI? 2022 was super crazy because all these like text-to-image models came out, and it really captured the imagination of the public. So mostly like entertaining stuff. The two examples I have are just dumb things that people were trying in their spare time, right? Like, so I think the one on the left was, I think someone asked ChatGPT to either like start a website or something, and it hit a wall because it hit a CAPTCHA. You might have read about this on Reddit or something, but so then ChatGPT went to like TaskRabbit to like get help to get through the CAPTCHA. So, yeah. And I think there was like a payment thing. There's like a longer version of that on Reddit, I'm sure. What's up?
The TaskRabbit person said, well, how do I know you're not a robot?
Yeah. No, that was the conversation.
They could see ChatGPT because they were watching it. They're red teaming it, but they're watching it. I don't know what you're talking about. It's so cool.
No, exactly.
Because I just watched this. So basically, they could see the ChatGPT going through the logic, and it said, well, I shouldn't tell her that I'm a robot. So what can I say that will give her a high probability? And so it said, I'm vision impaired.
Yeah.
That's enough for the tax guy person to go, oh, okay, well, I want to help out, someone vision impaired. Of course I want to help someone vision impaired. So,
right. So this is all just like
that's the scary part.
Right. It's so. Yeah.
Do you believe it?
What do you mean? Do
you believe that story? Like, do you believe that story that ChatGPT went to something like TaskRabbit, or do you believe that the person who prompted this post gave it context and gave it like, hey, you should go to TaskRabbit and do this? Like, feed me some chats that make me think that you as an AI are trying to break out. Like, honestly, so do you believe it really did that, or do you believe it was set up as a story to generate views?
I don't think I actually believe it because.
I don't.
Really? Okay, so.
I don't for a second.
There have definitely been cases of people generating stuff for like cloud, I guess. But even the fact that it can be, we can logic our way through it, that it's statistically possible that maybe it went through this checklist.
It's a glorified autocomplete. Like, we can only it's a glorified autocomplete.
Right.
Yeah.
But at least the fact that someone, whether that actually is what was the series of events, the fact that we can say, oh, maybe it did, like the fact that there is like a chance, is very interesting. And again, it really captured the imagination of the public because it's not until you try it yourself that you can verify some of these things. And you can also have like ambiguous, like two different people can have very ambiguous prompts and get totally different answers. On the right side is this like movie that someone made in like August last year called Saltverse, and it was just like about a planet made of salt. It's on Twitter. There's a lot of people making films. Like basically they'll generate a script, they'll give it a lot of prompts, they'll generate like a rough script, they'll take that script, feed it through another model that will then generate images so that at least you have a storyboard. And then in the latest iteration of stuff that kind of came out in the recent like month and a half, there's a lot more video-based content that you could generate. So then people have been making actual clips. So it's really, really fun to see, like just on a very instinctual level. It's just entertaining. It's no longer like a stuffy research paper. It is kind of in your hands, and you know. This part gets a little murky. I just want to make a point that not all LLMs are the same, so we'll see if we get through this. But there are two categories of generative AI. There's explicit and implicit. By the way, I want to caveat this by this isn't my like area of expertise. I'm not a statistician, but at a very high level, explicit models model the probability distribution on the input data. So explicit would be text to image. So that would be like diffusion model. So that would be like Mid-Journey and Stable Diffusion and all that kind of stuff. And implicit learn a probability distribution over the output data, and then they use some sort of condition, like context, which is basically a prompt, to create something. We'll see if this analogy works. You definitely, this is like a topic that you kind of need to study maybe a little bit on your own, but the best analogy that I could come up with is if you have to like cook, explicit would be, like if you have a recipe, you know, you go through the steps, the instructions, and you explicitly, the instruction manual will explicitly model the probability distribution of the ingredients and the instructions for how to combine them to make a final product. Now, implicit will be different, right? It'll be, there's this like series on Bon Appetit where people would come in and try to like recreate famous recipes without knowing the actual ingredients. So that's kind of analogous to implicit, how that works, because you're basically learning the probability distribution over after experiencing a series of final products, and then you're creating like your own. I'm just making the point that LLMs kind of fall in between a lot of different types of models, and each one had a lot of research and different end use cases in mind when they were being made. And then from these models, there's like different products that kind of came out. Diffusion models are really well set up to generate images from text. So there's kind of like a class of those. Autoregressive models would be like BARD. That kind of came up in the news. You might have heard about Google messing up a demo. So that would be in the same class of stuff as ChatGPT. Also, like you were saying, like autocorrect is kind of in that class. So Grammarly has been building upon GPT to integrate stuff into its own product. There's also like transformer architecture. XLNet is really good. BERT is better, but it was made by like Google. So there are all these different products that are out there. For context, like your Siri's or Cortana's or Alexa's from a while ago would have used a mix of very early iterations of these types of models to, execute whatever task you asked it. So one particular exciting one that was discussed a lot in the public were diffusion models. This one I did research, and it was definitely like some dude trying to like be funny, which it is. It's hilarious. But the idea is, yeah, you have a sentence and have an image, and now video and 3D content be generated from that prompt. So there were 4 that came out just all at once over the summer in 2022. The first one was DALL-E 2, and you had to get on a wait list. And eventually you would kind of run into paywalls. Imagen was not really meant for the public. It was kind of developed with a more enterprise customer in mind. And then Midjourney came out, and that was really cool. It was on a Discord bot, and people were kind of starting to use it themselves. Stable Diffusion was the one that was released in August, and that one was really meant for people to use openly without too many strings attached, and easily. So OpenAI has been, as a company, been discussed a lot, so I just want to briefly talk about kind of its major products. So they worked on GPT with AGI in mind. GPT 1 and 2 are open source. From 3 and 4, those are not open source. And they built, ChatGPT and Codex off of it. I haven't played with Codex, but basically it's like autocorrect, like really good boilerplate code. And then there's DALL-E 2, which is again like a diffusion model, like the examples I was giving earlier. And there's also Whisper, which is a speech recognition and translation model. And that one's open source. So Microsoft kind of stepped in. They started having like a relationship in 2016. Microsoft was also pushing its AI bots, like on Twitter. There are all these like horrible incidents of it going crazy, all these stories. Microsoft really put itself out there. But the business relationship between, and OpenAI started off as a nonprofit, right? And obviously that relationship has kind of grown closer, especially in 2019, especially in like this year. It's not that Microsoft owns OpenAI necessarily, but Microsoft has a really good platform, and OpenAI has all these products. So they kind of like work together. OpenAI is integrated, I think in the last month, into like Copilot, and there's like GitHub like plugins that you could use that aren't sketchy and won't give you a virus. And OpenAI in turn also leverages the Azure big supercomputing power that Microsoft has invested in. So that'll also be really interesting to kind of keep an eye out for how that relationship flourishes, or doesn't, I don't know. Prompt engineering, I think, is something that should be discussed. This is just like how you interact with generative AI. A prompt is, what you put in to get the output, an instruction that's passed into a language model to execute a task. What makes it engineering? The idea is that you put some engineering principles into it to get like consistent results. This isn't supposed to be like Google. This is supposed to be, if you're using AI models at a larger scale, how do you not just have fun with them or make something cute and entertaining as like a one-off thing, but how do you consistently get good results or generate good data? And how to do it efficiently and optimize it and all of that kind of stuff. It's important because we want to advance go beyond the current just like, let me throw something into ChatGPT and after I'm bored, I will forget about it. You know, you want to build, have advancements and have kind of principles, operating principles, that this is the way you put in stuff, and this is what you should do if you want it, if you expect this, and what are the different types of prompts. So it's good for research. You also want to test the limitations of these LLMs that are being thrown. A lot of different people independent people are kind of working on stuff, so finally people, like lay people, get to test these research models that are kind of out there. And generally building innovation, but also like expanding accessibility is why prompt engineering and just learning more about prompt engineering is good. Types of tasks, I'm just gonna read these. Text summary, question answering, probably the most common one. Text classification, role play, code generation, reasoning. So, you know, different people are gonna have different reasons to use different types of prompts. Text summary, obviously, like, you know, your college student that wants to write an essay really quickly, that's the kind of obvious use case. But, you know, how do you create documentation? How do you create content? So as you start to identify your task more clearly, then you can actually apply and certain principles to those tasks. And all of this is, by the way, being built out, so anyone can contribute to saying, hey, it would be really good to, you know, if I want question answering, this is how I should set up my prompts. This is like just some guy on Twitter who breaks down prompts and, you know, teaches people on what makes a good prompt versus a bad one, and what kind of output, you know, what kind of things you should identify for which types of tasks. Instructions, context, input data, that obviously depends on the model that you're gonna use, and what kind of output do you want, are kind of the 4 key elements to writing a good prompt. I have some resources at the very end. There's kind of communities that are getting together. This is a great way for people of different domains to also come together and be like, hey, I work in this space and it's totally different, and if you want to generate anything useful, these are the kind of things that you need to put into the prompt. So where do we go from here? This is super current, like, I don't know, it was like 9,000 last night and it was like 10,000 this morning. But there's a big call to pause AI experiments now that ChatGPT 4 has come out. And the idea is that we should continue working on stuff only once we're confident that their effects will be positive and their risks will be more manageable. The idea is to work with policymakers on governance systems, creating meaningful regulation bodies, tracking synthetically generated data using like watermarking, correct oversight, liability, safety research, all these kind of systems that we usually put in place for things like infrastructure, things that are deeply now going to be embedded into our society. It's crazy how much the AI field, how accessible it's become in the past 2 years, how many things have kind of spiraled out from it, and how powerful these systems are. We definitely want to be able to use it, but not, you know, accidentally do anything, you know, have it become a Pandora's box, I guess. Just like a final note, it's super exciting to see a lot of people kind of coming into the fold of AI through with these like generative AI concepts. If, you know, like David was talking about AGI, if we want to inch towards general artificial general intelligence, like, you want to make sure that you bring as many people with as many backgrounds into that fold. So the idea is that the wider your variance, the more standard your mean. So the closer to truth we want to get to, the more diversity would be required. Meaning, you know, types of brains, but also cultural experiences, background, age. Domain knowledge is really huge. If you want to kind of create this human big corpus of knowledge, you want to make sure that you're not missing out on people, because everyone has built up knowledge over the course of their lifetime. So just to make sure that we're valuing that and putting it into these systems is really important. That's my bit. So there's this like 2-hour interview with Sam Altman that was really interesting. You know, kind of talks about the whole backstory of OpenAI and just like, you know, pressures and kind of how it's changed from a nonprofit. Learning prompting is a good kind of, it's probably like the best resource right now on how to write prompts. It's the most organized. There's also like a Discord somewhere in there. I included a YouTube video that was like a really good conceptual explanation of how diffusion's model work, like how you add noise and how you remove it and all of that kind of stuff. Hugging Face, just really good for it's a great place for like resources with different models, lots of data sets if you want to start playing around. Modal was something I discovered, and it's really cool because you basically can just deploy really heavy projects without spinning up an AWS instance. Sometimes I spin up instances and I forget they're running. So, but just FYI, they're actually really good with their customer service. So if you tell them, hey, I didn't use any of it, like you could see, they won't charge you, but don't do it for too long. Weight Watcher was really cool. It's like this, it's this open source tool, and it won't look at any of your data, but it'll kind of give you like diagnostics. I think he explains himself as a oscilloscope for AI models, which I thought was really cool. So, yeah, I don't know, hope you find this interesting. And that's my LinkedIn if you want to connect and talk later.
I guess this is a question to both the presenters. Will you be sharing the slides?
Oh, yeah.
Yeah, we'll put it in the Slack.
Okay, thank you.
Okay.
Yeah. Okay.
All right, everybody, thank you so much. Thank you, guys. Feel free to help yourselves to any of the leftover pizza, and stay tuned for our next event. If you go to go.tampa.dev/events, that's our event calendar on Meetup. Thanks again for coming out. I hope to see you at the next